Ladies and gentlemen, boys and girls, children of all ages, welcome back to another question. In these videos, I go over exam techniques, how to approach the question, and the common mistakes that can be made. Today's topic is similar shapes. After this video, if you have any questions about this specific topic or any question at all regarding any other topic, please do let me know in the comment section below, and I'll try and go over those topics as soon as I can. So this question says, two cones, P and Q, are mathematically similar. The total surface area of cone P is 24 centimeters squared. The total surface area of cone Q is 96 centimeters squared. The height of cone P is 4 centimeters. Work out the height of cone Q. So we haven't done many geometry questions. So what I'll try and do for this question is not only are we going to highlight the important parts, but we are also going to draw out the important parts, and you'll see what I mean by that in a second. Okay, so here we have two cones, P and Q are mathematically similar. So they are mathematically similar. And what that means is that all their lengths will be in ratio to each other. All their widths, all their heights, all dimensions will basically be in a ratio to each other. The total surface area of cone P is 24 centimeters squared. All right. And the total surface area of cone Q is 96 centimeters squared. The height of cone P is 4 centimeters. Work out the height of cone Q. So all of this information is really important. We are already given the height over here, and we are trying to work out the height of cone Q. All right, so let's see what we can do. With this question, we can draw out the important parts. So it says work out the height of cone Q. So we're trying to figure out the height of this cone. And because they are mathematically similar, we will know a few factors that we can figure out. Well, we can write down the important information in a table, and that'll make it easier, hopefully, for us to see what's going on. So we have shape P and shape Q. If we want to look at their heights, the height of P is 4, and the height of Q is h. What else do we know? Well, we know the surface area. The surface area of P is 24. The surface area of Q is 96. So what we should remember from shapes that are mathematically similar, so whatever the scale factor for lengths is, the same scale factor will be squared for surface area, and it will be cubed for volume. Here we have surface area, so if we try and find out the scale factor of the area scale factor, how do we get from 24 to 96? So to figure that out, we would do 96 divided by 24, and that gives us 4. So we are multiplying by 4. And now that we know that the area scale factor is multiplying by 4, that means 4 is equal to k squared, where k is a scale factor for the sides. All right, which means that k will be equal to 2. So to get from 4, we'll have to multiply by 2. Now, if we were trying to figure out the volume of any of the shapes from going from P to Q, then we would have to multiply by 8, and you would realize that when you figure out the volumes of these shapes. Okay, and because we're doing 4 times 2, then our height will be equal to 8. And that is our answer for this question. The height of the cone is 8. So now that we know it's 8, we can say that it is twice as tall. All right, but this question comes in 2 parts. Now the second part of the question is the volume of cone P is 12 centimeters cubed. Work out the volume of cone Q. Well, we know that the scale factor of the sides, the scale factor is equal to 2, as we figured it out. And this is for sides. For the area, it would be 2 squared, which is 4. And for volume, scale factor would be equal to 2 cubed, which is 8. All right. An easy way to remember how the scale factor changes is by looking at the units. So over here we have centimeters cubed. So what we're doing is we are going to cube our normal scale factor. So this was from the previous part of the question. It says work out the volume of cone Q. So to go from P to Q, we would be multiplying by 2 if we were looking at the sides. We would be multiplying by 4 if we're looking at the area, which we already have done. And we would be multiplying by 8 to find the volume. So we are going to be multiplying by 8. And here we have 12 centimeters cubed. So once we multiply this by 8, we should end up on 96 centimeters cubed. And that is our answer. So it's really quite simple how we're going to do this. All we have to do is understand what our side scale factors are, our area scale factors, and our volume scale factors. The side scale factor is not really the correct term. We normally say the linear scale factor, but it's just to tell you that it's the size that we're looking at. All right, and here we have the answer, 96 centimeters cubed, and that is the volume of cone Q. I hope this video was informative. If you have any questions about this particular question or any question of any topic at all regarding maths, please do leave them in the comment section below and I'll get to them as soon as I can. All right, stay safe.